Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Chuchu, who has just completed the course ROS Basics in 5 days, and she'll be giving us a presentation on that. So without any further ado, let me now hand over the platform to her so that she can begin her presentation. Alright Chuchu, whenever you're ready.
Yeah, okay, so today I'm going to present a ROS program demo. This is assignment for the course ROS Basic in 5 days from Construct. I'll just launch my program.
Okay.
Now the first node in function is the wall follower service node. Now the robot is trying to locate turning.
Can you enlarge the robot window a little bit more? The camera
Yeah.
window, yes. I think you can minimize the terminal for now. Okay, that's cool. That's okay.
Yeah. So now it's trying to find the nearest wall using laser data. Oh. So
that is quite quick.
Okay, now so now it's starting following the wall. Turning to the second node, the wall follower node.
All right, it's turning really quickly. How did you set angular velocities?
I know. It's something.
Did you just pick very high values, or you were trying to correct for something really quickly?
It depends on the location, which corner it's in. Sometimes it recognizes the.
Okay. All right. So you're trying to make sure it compensates as quickly as possible before it crashes.
Yes.
Okay.
Yeah. Now it's in the wall following mode.
Okay.
I mean, while the robot's doing this thing, we can just cover some basic ranges.
I think
it's going there. Yeah.
We do have seen that it manages to follow the wall. It didn't stop though. So
yeah. Let me just restart the process so we can observe it's following. It's. Oh, what do you mean? Like.
I think you can terminate. You can terminate the program. It's okay.
Yeah.
Before you start explaining the code.
So I'll start again or.
No. Can you now go through your code? So we want to understand what did you do to make it exhibit that behavior, and which ROS concepts did you have to use? Right? Did you have to use actions, services, topics? What did you do? We want to understand that stuff.
Make very detailed comments. So the first is the global variables. Now the scan callback, that's the center of the whole program.
I think your wall follower.py isn't loaded yet.
That's the wall find wall node.
Yes, the find wall. Yes, the find wall. Yes, that's the one that isn't loaded because we cannot see.
Wait, it's something with the zoom again?
I don't think so. Can you try opening a different script?
Wait, it's I don't know. Sometimes it works.
Can you hear me?
It's, yeah. Now it's there. Or.
Okay.
Yeah.
So it's probably me who is experiencing some lag. Okay. So let's wait for it. Okay, now it is loaded. Okay. You can go ahead and start explaining. Yes.
Yes. So the center of the screen of the program is a scan callback. So it's for laser scan data processor. like I do some filtering and like rule out all the invalid readings.
And which ones of those invalid readings did you have to filter out?
It's like the ifs and nans, that like this corrupted ones, like instead of numbers, like it sent nuns, like yeah.
All right.
Just to the, so like I use this sector based, just like our task in the topics one. Also, autonomous something in the task, there was a sector based algorithm, so I borrowed that one to divide the based on sectors to divide the laser scan.
All right. And how many sectors did you use?
6, the right, front, center, front, left, rear.
Okay. All right.
And yeah, so like how to calculate the minimum distance. So like it's based on the like the laser, which sector has the minimum distance detected, and then turn to that sector.
Okay. All right. So this is the find wall.
Yeah, this is find wall. Yeah.
Okay.
So I add some.
Okay, without referring to the code, can you like give me a detailed explanation of how it finds the wall? Like what form of processing does it do to the laser scan data to find the wall? In what way is it different from a corner or anything else?
Oh, wait. Let me just.
So
like it's okay. So it needs to locate the nearest wall and rotate to face the wall and approach the wall. I use the sector-based, like the laser scan to analyze the data to get a more robust detection, right? So. Wait. Which is your question again?
I was saying, without referring to the code, can you explain to me the logic behind how your robot finds the wall, right? I want to understand what form of processing did you have to do for the robot to know that this is the wall and I'm supposed to move towards it. How does it differ from any other obstacle?
It doesn't differ from anything. All the obstacles are recognized as wall, actually. So it reads from the laser beam which sector of the beam. I didn't average, so like the sector is 15 degrees, and the average of the detection, if one of the sectors has detected the closest the minimum distance to anything, any obstacles, then this sector would define as the angle to turn to when the robots rotate, to face the wall.
Okay, so if you're averaging like a 15-degree sector, right, that is about the space that will be occupied by an obstacle. Why did you choose to average only that small size of ranges data, right? Because you want to be sure that it's a wall, not an obstacle, right? So what stopped you from taking in a wider range and averaging out those laser scan data?
I didn't imply anything. Any obstacle would be recognized as wall, actually, in my algorithm. I don't know if you mean like if the wall is not as like it can detect obstacles from how tall it is, or what do you mean? Basically, that's not what I suppose the laser can do, because in my perspective, the laser just detect anything in the close. at the same dimension. So anything in the clothes is recognized as wall. Like if you put another robot in the clothes, then it will be recognized as the clothes wall.
Okay, fine. I think I do get what you mean, because as a result
Yeah.
of the way the laser works. But in this case, isn't it your objective was to make sure that the robot follows the wall, right? That's why I'm
Yeah,
asking.
that's why.
Did you have to do anything different? You're saying to me you didn't have to do anything different, whereas it is actually expected of you to be able to differentiate between obstacles and the wall, so that you can
Yeah.
keep the wall on the right as your
I
robot
I
goes around.
I add some like error handling, like for safety in the wall following. So like if it detects any obstacles in the front, it will turn a sharp left. So like if the robot keeps doing that, obstacle sharp left, it would eventually be following the wall. Like because we have very naive, like, very simple environment. So that's basically my way of error
All right,
handling.
all right. I see.
Yeah.
Okay, can you let's see your wall follower.py script then, because I think the find wall, you said everything can be deemed to be
A wall, yes.
all right, that's the one. Okay, let's see the wall follower.py. That's the one we want to see. And can you explain to me what ROS principles did you have to use?
So it's implementing the SS assignment required as find wall service to call first, right? So the DOM recording to call second, like, and then after it's called and success, then it starts to follow the wall. But even if it failed, like in our case, it fails to find the wall, it will just starting the main loop as following the wall. It will recognize anything on at the right hand side as well, and do error handling when something is quite odd. Obstacle sharp left, obstacle sharp left, and somehow it works.
All right, I get that. Okay, and the odom result, can you explain that script as well? Can you tell us what you did within that script and how does it work?
Yes. It's so like I comment everything. So it's supposed to keep a record of the position change, right, to the starting point, and calculate all the distance being traveled. So it should be it's supposed to be it prints the result every 10 seconds. I put here. Otherwise it's annoying. And in the end, give the feedback when the lab is done.
All right. Thank you very much, Chuchu, for your presentation. So just hang on and we will wrap up conversation here, okay? All right, everyone, this was Chuchu's presentation, and would like to wish all those of you who would like to give this course a try to do so, and then you can come and showcase your work. So until next time, keep pushing your ROS learning.